Hello, good day everyone. Into this tutorial we are going to talk about numbers. Numbers are essential in mathematics. In fact, they are the building blocks of mathematics. We use numbers every day in our daily activities. We use these numbers to count objects. We use these numbers to level objects. We use these numbers to measure the length of objects. So into this tutorial, we are going to look onto the various types of numbers, the relationship between them, and how we can be able to identify them. So if you're new here, consider subscribing. Press the bell icon so that you will be notified whenever I upload a new content. And if you're watching this video from Facebook, kindly go to YouTube, search for Tambol Math Class, subscribe, share to your learning colleagues, and don't forget to hit the like button. So the first group of numbers I want to talk about are we have real numbers and we have imaginary numbers. Let me first of all talk about real numbers before going to imaginary numbers. Think of any number in this world, any number. That number is a real number. So, if every number you can think of is a real number, what about imaginary numbers? Imaginary numbers, they are the complement of real numbers because they are numbers, but they are absent here. So we call them imaginary. And in mathematics, they are denoted by I. Remember, in our simple arithmetics, we say we do not have square root of negative numbers. So since we don't have a square root of negative numbers, the result of a square root of a negative number is imaginary. So imaginary number in mathematics is defined as the square root of -1. If you take the square root of -1, you shall get an imaginary number. And if we square both sides, we can have I squared equals -1. This means that if we square an imaginary number, we are going to obtain a real number. And another way you can remember imaginary numbers is in solving quadratic equation. You know, if you have a quadratic graph in this form, so the 2 points where the parabola touches the x-axis are the real solutions of that quadratic equation. But sometimes we may have a quadratic equation that passes without touching the x-axis. So in that case, we say the solution is imaginary because the parabola didn't touch the x-axis. So this is another way. Coming back to real numbers. Real numbers are subdivided into two forms again, two categories. We have the rational numbers and we have the irrational numbers. So what are rational numbers? Rational numbers are those numbers that can be expressed as a ratio of two integers. We are coming to integers. I'll explain integers in details for you. Once a number can be expressed as q over p, where p and q are all integers, but p is never equal to 0 because to express two numbers in ratio, the denominator will never be equal to 0, because if the denominator is equal to 0, we say that statement is undefined. So once a number can be expressed in this form, we say it is a rational number. Example of these rational numbers, we have a whole number like 2, because 2 can be expressed as a fraction. So we can say 2 over 1 is the same thing as 2. We can say 10 over 5 is the same thing as 2 because 10 divided by 5 is 2. We can say -20 over -10 is the same thing as 2 because negative cancel negative. 20 divided by 10 is 2. So these integers, all integers are rational numbers. Another form of rational numbers, We may have ordinary fractions like 1 over 2. 1 over 2 is a fraction. It's also irrational because it is expressed as ratio of 1 and 2. 2 over 3, 4 over 7, they're all rational numbers. Another form of rational numbers is when we have decimal numbers like 2.3. 2.3 can also be expressed as 23 over 10. You can see because 23 divided by 10 will give us 2.3. We can have 1.45. This can be expressed as 145 over 100. This is the same thing as this. Therefore, this decimal number can be expressed as a rational number. But look at it, we have a terminating decimal number. Terminating in the sense that it has an end. We have only 2 decimal places here. Sometimes we may have non-terminating decimal numbers like 0.33333, but they are recurring in the sense that 3 is repeating itself. It keeps on repeating, but it is non-terminating. These types of numbers are also rational numbers because it can be expressed as 1 over 3. In our next class, I'm going to show you how to transform these decimal numbers into fraction or rational numbers. So terminating decimal numbers and the non-terminating decimal numbers with recurring values, we see they are all rational numbers. So coming back to irrational numbers. Irrational numbers are numbers that cannot be expressed as the ratio of 2 integers. Example, a square root of a rational number, any rational number, a square root of rational number, if and only if that rational number is not a perfect square number, we see it is irrational. We know pi. We say pi is an irrational number because it has non-terminating decimal values that are not recurring, which is approximately equal to 3.14159 and so on and so forth. You see these numbers, they are not repeating and they are non-terminating, so we say it is a rational number. Square root of 2 is something like 1.41. It keeps on going, non-terminating, non-recurring, so it is a rational number. We cannot find 2 values that can be expressed as the ratio of this. So coming back to rational numbers, we have other subset of these rational numbers, and the first one we have are the integers. Integers are just those numbers on the number line. This is a number line. Every number you can see on a number line is an integer. We have the positive numbers, we have the negative numbers, including 0, they are all integers. Excluding the numbers in between them. So, under these integers we have whole numbers. We have whole numbers. Whole numbers are subset of integers because all whole numbers are integers, but not all integers are whole numbers. Alright, so whole numbers begin with 0 and any other number to the right. So we have 0, 1, 2, 3, 4, 5. In that order, we call them whole numbers. They are all whole numbers. They are referred to as whole numbers. In another word, we see they are complete. They are complete. You can only address one person as one. If that person is absent, we say there is nobody there, which is referred to as 0. But you can never say we have half a person. You understand? So they are all whole, complete. So under these whole numbers, we have natural numbers. Natural numbers, we see they are the counting numbers. 1, 2, 3, 4, 5, 6, in that order, excluding 0 and every other negative number you can think of. But all the positive numbers from 1 to infinity, we call them natural numbers. They are the counting numbers. If we are to count, we start from 1. We start from 1, 2, 3, 4, 5, in that order. So this is all I have for you today. Thank you for watching. Do have a nice day.